Hello. Yeah, in this video we shall be looking at the basic ideas of differential calculus. Okay, in our previous video we were able to deal with the limiting value of a function. So here we're going to look at how we can apply the limiting value of a function to find the derivative of a particular function. Now, let us look at differentiation from first principle. Definitely, differentiation from first principle makes use of the limiting value of a function, the idea of the limiting value of a function. Now, what I want you to bear in mind in this case is that when we have a function y equals to f of x, okay? Now, we do write some symbols as dy dx, that is the difference in y over difference in x, that is change in y over change in x, is f prime of x. Okay, now there's something I want you to bear in mind. This dy dx is equal to the limit as change in x tends to 0 of change in y over change in x. So all we are driving at is to get this particular function and then take the limit of it as change in x tends to 0. So from there we'll get the value of dy dx. So let us take, for instance, we want to differentiate the function y equals to x raised to the power 3 from first principle. So how do we do that? So we can just take any change in y. If there's any change in y at all, there's going to be a corresponding change in x. Okay, because x and y, they are closely related in this equation. So let's say y plus change in y. So we are going to add the little change in y to it. So it will be equal to x plus change in x, because to every change in y there is always a corresponding change in x. So we're going to have y plus change in y equals to, opening this bracket, we're going to have x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cube. Don't forget, what we are driving at is to get this particular expression, change in y over change in x. So from there, what do we have here? We have y plus change in y. Okay, no, let's take it this way. Let's transfer y to the other side, because what we are looking for is change in y over change in x. So we have change in y to be equal to x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus, we are transferring y to the other side, minus y. Don't forget that y is equal to x cubed. So we're going to have change in y to be equal to x cubed plus 3x squared change in x plus 3x change in x squared plus change in x cubed minus x cubed. So x cubed minus x cubed is gone. So we have delta y to be equal to 3x squared delta x plus 3x delta x squared plus delta x cube. Don't forget, we are looking for delta y over delta x before we can take the limit. So let us now observe this. What if we divide both sides by delta x? So dividing both sides, dividing through by delta x. So we have delta y over delta x to be equal to 3x squared delta x over delta x plus 3x delta x all squared over delta x plus delta x cube over delta x. So we have delta y over delta x to be equal to 3x squared plus 3x delta x plus delta x all squared. So now we have successfully gotten an expression for what? Delta y over delta x. So we can find dy dx now. You recall that dy dx is the limit, okay? Is the limit as change in x tends to 0 of what? Delta y over delta x. So we're going to put this value is the limit as delta x tends to 0 of what's our delta y over delta x? All of these. 3x squared plus 3x delta x plus delta x squared. Okay? So finally, if you substitute 0 for every delta x in this place, we're going to have 3x squared plus 0 plus 0. If you put 0 for delta x and put 0 for delta x over there. So therefore, dy dx equals to 3x squared. So since y is x cubed, then dy dx equals to 3x squared. I want you to go and try this. Y equals to x cubed or x squared. What if y equals to x squared? What's going to be the differentiation from first principle? What about this? Y equals to 1 over x. What is going to be your result? What about this? Y equals to 1 over x squared. Okay, go and try those ones. In the next video, we're going to proceed. Thank you and God bless you.